You ever step outside and the air just feels heavy? Like a warm, wet blanket just dropped on you? Well, the reason for that is all around us, hiding in plain sight. Today, we're going to pull back the curtain on the hidden science that secretly governs our comfort: psychrometrics.
Okay, let's do a little thought experiment. It's 30 degrees Celsius out, that's about 86 Fahrenheit. Now, if you're in Phoenix, Arizona, it's hot for sure, but it's manageable. But take that exact same temperature and drop yourself in Miami, Florida. Suddenly, it's oppressive, it's sticky, you feel miserable. So what gives? How can the same number on a thermometer feel so incredibly different?
Well, the secret isn't actually about the heat. It's about what's in the air that's carrying that heat. The answer to our little Phoenix versus Miami mystery is right there, hiding in the air itself. So, to really solve this tale of two heats, we have to get into the invisible properties of air. We need to understand the relationship between air and water. And believe me, there's a whole field of science dedicated to exactly that. And that science has a name that's a bit of a mouthful: psychrometrics. Yeah, I know, it sounds super complicated, but all it really is the study of moist air, which, let's be honest, is the air we live and breathe every single day. This is basically the instruction manual for everything from the weather forecast to your own personal comfort.
So let's unpack the air, shall we? To figure out what's going on, we have to see what it's actually made of. And when it comes to our comfort, it really just boils down to two key parts.
First up, you've got what scientists call dry air. Now, this part is incredibly consistent, pretty much the same everywhere. It's about 78% nitrogen, 21% oxygen, and then a tiny little 1% sliver of other gases. You can think of this as the stable, predictable background character in our story. But here's the thing, we don't actually breathe pure, dry air. The air we experience is what's called moist air. And it's a simple recipe. It's that constant dry air plus one very critical, very unpredictable ingredient: water vapor. And let me tell you, that water vapor, that's our troublemaker. So, this brings us to the million-dollar question. If this water vapor is the key, how do we measure it? And more importantly, how much of this stuff can the air actually hold onto at one time? Now, the most fundamental way to measure this is something called the humidity ratio. I want you to forget the percentages you hear on the weather report for a minute. This is way more direct. It's a simple ratio. For every kilogram of dry air, how many grams of water vapor are mixed in? It tells you, literally, how much water is actually floating around you. But here's the catch. Air is not an infinite sponge. At any given temperature, it can only hold a certain amount of water vapor before it's completely full. When it hits that absolute maximum limit, it's reached a state we call saturation. It just can't hold anymore. Okay, so let's put some real numbers on this. Let's say it's a cool 10 degrees Celsius or 50 Fahrenheit. At that temperature, 1 kilogram of air can hold, at most, 7.6 grams of water. Okay? Got that number? 7.6 grams. Now watch what happens when we heat that same air up to our Miami temperature of 30 Celsius. Its capacity to hold water just explodes. It can now hold 27.3 grams of water. That is more than 3.5 times as much. And this right here, this is the absolute heart of our mystery. Warmer air is simply thirstier air, a lot thirstier. Okay, so we've got the physics down. Now, let's connect it to our own bodies and finally understand why all this science makes you feel so sticky and gross in Miami. It all comes down to your body's built-in air conditioner, sweat. But here's the secret. Sweating by itself doesn't cool you down. It's the evaporation of that sweat that pulls heat away from your skin. So in humid Miami, the air is already almost full of water vapor. It's like trying to pour water into a glass that's already full. The sweat on your skin has nowhere to go. Evaporation slows to a crawl, your cooling system basically fails, and you're left trapped in your own body heat.
Oh, but it gets worse. On top of that, moist air physically carries more heat energy. Think of it like this. Dry air is like a hot sponge, but moist air is like a hot, wet sponge. It's heavier, and it packs more of a thermal punch when it hits you. So not only is your personal AC broken, but the air itself is literally hitting you with more heat. It's a total double whammy.
So understanding this problem is one thing, but this science is also the key to actually solving it. Let's take a quick look at how we put psychrometrics to work every single day. You see, an air conditioner's real magic isn't just making the air colder. That's only half the battle. The other absolutely crucial part of its job is dehumidification. It works by chilling the air down so much that it can't hold all that water vapor anymore.
It forces the water to condense back into liquid. That's the water you see dripping out of an AC unit. It is literally wringing the moisture out of the air so you can feel comfortable again.
All right, so let's do a quick recap. The air we breathe is a mix of constant dry air and shifty, variable water vapor. The most important thing to remember is that warm air can hold way more water than cold air. This matters because high humidity shuts down our body's cooling system, evaporation, which makes us feel hotter. And finally, that's why your AC is a 2-for-1 deal. It cools the air and yanks the moisture out.
So I'll leave you with this final thought. We've just seen how the invisible physics of the air completely dictates our daily comfort. Now, as our planet gets warmer, the air is going to get thirstier too. It's going to be able to hold even more moisture, making extreme heat feel even more dangerous and oppressive. The real question then becomes, how will mastering this hidden science of the air redefine our ability to live on a changing planet?